Hello guys, welcome back to Math Zone African Motives. We are still on our revisions and this is our paper 2 exam that we are going to consider, which is for our mathematics. That was written in June 2025. So we are going to consider these guys from our KZN province. If we are going to obtain other question papers, we are going to work on those, preparing for the examinations that we are going to be having in this June. All right, so that was it, guys, out of 102 hours from what we are given. So just make sure you go through the instructions and information. That is the most important part. Go through each and every part. If necessary, round off answers correct to 2 decimal places unless stated otherwise. Just make sure each and every part you understand. And also you can download the question paper. If you check the comment section, I'm going to put a link where you can download the question paper or the description of the video. So let us quickly have our questions here. Question number 1. On 1.1, you are given in the diagram below, there are points A, B, and C, which are vertices of a triangle. So you're given the vertices of a triangle. We have got angle alpha, angle theta are angles of inclinations of AB and AC respectively. Then there's angle BAC, which is equal to what? To beta, according to what we are given on our diagram here. That's our point A, B, and C, the vertices of what? Of a triangle, triangle ABC. Then angle theta and angle alpha being our angle of inclinations. And we have got this angle beta, which is A from B to A to C. That is what we are given. So from this diagram, we are given 1.1.1. Calculate the length of AB. Leave your answer in simplified. That is the simplest form. All right. In what? Simplified said form. All right. The length of AB. So remember, the length can be taken if we are to consider 2 points. All right. We have got A and B. So we can simply obtain the length of AB from the formula. We can use y2 minus y1. You can even use the x value, the x2 minus, right? Anyone that you can use the x values. First, you can consider the y values does not affect, right? So that's our A. Just gonna call x1, and that is gonna be y1, and this is x2, y2. So substituting into the length formula or the distance formula, y2 is what? -2 minus y1, which is 10. We are supposed to square this. X2, that is -6 minus our x1, which is what? A -2. So this is what we're going to have, and we must square this. So that is it, guys. A negative and a negative is going to give us a positive. So we can evaluate everything at once, or we can simplify this bracket, which was going to give us 144, and this bracket, which was going to give us 16. Then we add 144 plus 16. All right, sorry for that. So here I wanted this, guys, 144 plus 16, which is 160. And in the simplest form, we can find the square root of what? The answer, which is 4 square root of 10 in what? Simplest form. So that is going to be 4 square root of 10 units. So that is the length of what? The length of AB in simplest form, right? So just consider the distance formula. And on 1.1.2, determine the equation of the line passing through B and parallel to AC. So it has to pass through the point what? Through the point B, all right? So we are given the point where the line is supposed to pass through the point B, but it is parallel to what? It is parallel to line AC. This is our line AC. So the line that we are going to have as it passes must be parallel to line AC. So remember that for two lines to be parallel, they are supposed to be what? Having the same gradient. So the gradient of the line that you are going to be having passing through the point B parallel to that, its gradient must be exactly equal to what? To the gradient of AC, since these two lines are what? Are parallel. Remember, the line that we're talking about is what? Parallel to the line of AC. So we just need the gradient from A to what? From A to C, right? So remember that the gradient of a line can be determined using the points, all right? And that's y2 minus y1 over x2 minus x1. So that's from A to C. So we've got our point A, and this is our point C. We're just going to call this one x2, y2. Let us substitute into our formula. Y2 is going to be negative 6 minus y1, which is 10 over x2, which is a 0 here, minus x1, which is what? Negative 2. So we can simplify this and obtain the gradient of what? The gradient of AC. Minus 6 minus 10 over 0 minus 2, all right? That's a negative 2 like this. And that was going to give us what? Negative 8. As the gradient of AC, it is the same as the gradient of the line that we are focusing with, since they are what? Since they are parallel. So having the gradient, we can determine the equation of the line, since we are told that it passes through the point what? Through the point B. So from y is equal to mx plus c, m is our gradient, substitute there, negative 8x plus c. Using the point B, we just going to take this as our x and this as our y from what? From point B, because the line passes through the what? The point B. So the y value at B is negative 2, and the x value at B is what? Negative 6. So that is it. We're going to find our C from there. All right. The value of what? The value of C. Negative, negative, that's positive 48. Then we're going to take this to the other side. It was going to be negative 48, which is what? Minus 50. Minus 2 minus 48 minus 50 is equal to C. So therefore, we are having the equation of the line as y is equal to what? From here, mx, that is minus 8x plus c. Our c is what? Minus 50. So that was going to give us the equation of the line, which passes through the point B and parallel to what? And parallel to AC. Just like that, all right? Let us consider another part where we are given on 1.1.3, calculate the magnitude of beta, all right? Correct to what? 2 decimal places for 5 marks, all right? Let us consider where the angle beta is. We can see that here, the angle beta is actually part of our triangle, which is affected here in this triangle, all right? We can consider that here, for us to determine the angle beta, all right, we can focus with angles that is like these angles, the 3 angles. We are supposed to work with them. As you can see, we are forming a triangle. And on this triangle, the angle theta is outside, that is the exterior angle, must be equal to the sum of these two opposite interior. All right, so we can actually play around from that and determine what the angle beta, since it is not direct. All right, so that's 1.13. To find the angle beta, we're simply going to obtain from theta, all right, minus what? Minus alpha. So subtract alpha from what? From theta, since we are considering theta as the exterior angle. So that is from the exterior angle of what? Of a triangle. So it follows that if we can determine the angle theta and the angle alpha, we are done. All right. So the angle theta being the angle of inclination of the line AC, it is affected by the line AC. And this line AC has got a negative gradient. All these lines like this, which has got a negative gradient, it follows that the angle of inclination is going to be 180 degrees minus what? Arctan of the gradient. So considering that theta is on the line AC, it is going to be arctan, the gradient of what? The gradient of AC, which is actually the magnitude. You always take this one as a positive value. All right. When substituting here, you consider the magnitude of the gradient. All right. The magnitude, the positive value when substituting. Yes, our gradient, we know that it is a negative for all these lines that is of this nature. So do we have the gradient of AC? Yes, we calculated this. That's a negative 8. So theta is 180 degrees minus the arctan of what? The magnitude of the gradient. This is negative. We need what? The positive value when substituting. That is the magnitude, the positive what? Value. So that was it. You're going to find arctan of 8 or simply use your calculator direct. 180 degrees minus shift tan, that is arctan of what? Of 8, which is 97.1. All right, so this is 0.13 to 2 decimal places. Let us just have our answers to 2 decimal places, 97.13. So that's 97.13. So this is our angle theta here. We can determine angle alpha using the same concept, all right? But as we are to consider the angle alpha in this case, it is from line AB, which has got a positive gradient. Remember, all these lines like this, they have what? A positive. These ones, they've got a negative gradient. So in that case, alpha is simply obtained from what? Arctan of the gradient of that line. We do not have to consider subtracting like what we had, 180 degrees minus. That is obtained. That is only done when we are working with what? Negative gradient. For a positive gradient, arctan of that gradient, you are done. But we do not have the gradient of AB. We only calculated the length of AB, not the gradient. So in this case, we're going to consider finding the gradient of what? The gradient of AB. All right, so let us just utilize this space here and work out our AB. That's going to be the gradient of AB, y2 minus y1 over x2 minus x1. So that's it. X1, y1 here, and this is going to be x2, y2. So let us simply substitute our values. Y2, that's minus 2, minus y1, which is 10, all right, over what? X2, which is negative 6, minus x1, which is what? A negative 2. So that was going to give us the gradient. We can just simplify this. Negative 2, negative 10 over what? Negative 6 minus what? Minus 2, which is going to give us a 3. So remember, we fixed our calculator. Let's go back to the normal mode. That's what? Positive 3. So as you can see, truly, we are obtaining what? A positive gradient from there. So the gradient of AB, that is 3. Let us use it here to determine angle alpha. So that's arctan of the gradient of AB. Remember, we obtained what? We obtained 3. So that was it. And obtaining our answer to 2 decimal places, that was going to be 71.57. All right, 71.57 degrees. So that's our angle what? Our angle alpha here. So to determine now the remaining angle, which is what? Which is beta, from the concept that I have explained here, that it is an exterior angle. Theta here is an exterior angle. It is equal to the sum of beta and what? and alpha. So therefore, we can find our angle beta from theta 97,13 minus the angle alpha of what? 71,57 degrees. So that was it to determine the angle beta, which was going to be 25,56 degrees. All right, just like that. Just like that. So you see, guys, the application of the angle of inclination, it is very, very important in the simplification, as it's going to help us to find other unknown angles, also with the properties of our triangles, knowing that the exterior angle is equal to the sum of what? The opposite interior angles. That part is also important for you to understand. All right, let us consider on 1.14, determine the coordinates of D if A, B, C, D in that order, in that given order, A, B, C, D like that, is a what? Parallelogram. So if we are given A, B, C, D in that order, all right, let us consider the order that we are given and determine the coordinates of what? The point D. All right, so this is what we're going to do. Remember, we're told it is given in that order A, B, C, D. So from A to B to C to D. So maybe we are going to have our point D somewhere there in the first quadrant. Did they mention even about this, that it is in the first quadrant? All right, they never mentioned, but it can be somewhere there since we are having what? A parallelogram. So let's say this is our point D. If we are to form a parallelogram, remember the concept of a parallelogram, that these lines, they are going to be bisect the diagonals from B to D with this diagonal that we are having from A to C. These diagonals that we are having, they are going to meet at a certain point. The intersection is the same where they meet these diagonals. So using that, their intersection simply will be the midpoint. So using that concept, guys, or understanding that concept alone, you can simply formulate an equation to say the point D, since we do not know, we're just going to call this one XY like this. So using the midpoint concept, the midpoint what concept, since these diagonals what? Bisect each other. Where they meet at this point, that point is the same. They do bisect each other. So M being the midpoint, taking -6. Remember, how do you calculate your midpoint, guys? The midpoint is going to be x1 plus x2 over 2. Then y1, for the y values, y1 plus y2 over 2. That's a midpoint. So in our case, we can say the x value, considering the midpoint of what? BD. So let me just write here the midpoint of BD is the same as the midpoint from A to what? From A to C. So the midpoint of BD, I'm going to take -6, the x value to the x value, -6 plus what? Plus x over 2. That is the x value. The y value, we are going to consider -2 and what? And y. So that's -2 plus y like this over 2. This is what you're going to have, which is the same as for A to C. From A to C, considering the x values, -2 and what? And 0. -2 plus 0 over 2. Plus, all right, sorry, we're going to separate. Remember, it's a point. The y value, 10 and what? -6. 10 plus -6 over what? Over 2. So these are supposed to be exactly the same because they do bisect each other. So that is the midpoint there is the same. So I can equate for the x values, I can form an equation. -6 plus x over 2 must be equal to -2 plus 0 over what? Over 2. In the same sense, for the y values, these two, they are the same. -2 plus y over 2 must be equal to what? 10 plus minus 6 over what? Over 2, which we can solve for x and y. All right, so here we can solve for x. The denominators are the same. Simply equate the numerators. Minus 6 plus x is equal to what? Minus 2. Minus 2 plus 0, that's minus 2. So x was going to be, add 6 both sides to get rid of this. So 2 minus 2 plus 6, that's positive 4. All right, so using the same concept here, the denominators are the same. So equate the numerators. That is going to be minus 2 plus y is equal to 10 minus 6, which is what? A positive 4. So to find the y value, simply add 2 both sides to eliminate these 2. So y is equal to 4 plus 2, which is what? Which is 6. So we have got the y value and the x value and the y value for what? The point D. Remember, that is representing the point D. So therefore, our point D, the x value is 4. The y value is what? Is 6. Just like that. So you see, guys, how do you play around this? This is just midpoint concept that you're simply going to use. All right. Then we are given on 1.3, calculate the value of x if these points that we are given, they are what? Collinear on 1.2. So remember, collinear, it's all about what? Same gradient. Same gradient. So I can just use points. In this case, I can consider the 2 points A and B and the point B, C, whatever that you want. So it follows that the gradient of A, B, it is the same as the gradient of what? Of B to C. So that is what you're going to have. It is about what? The same gradient. Remember, gradient y2 minus y1 over what? x2 minus x1. So that's the y2 value. Let us consider for this first part. I'm just going to take this one as x1, y1, x2, y2. So that's y2, 0 minus 1 over x2, 8 minus our x1 is what? X plus 5. This must be equal to the gradient of what? B to C. So if you consider B to C, y2, that's what? That's 2 minus y1, which is 0 over x2, x plus 7 minus x1. Our x1 is going to be what? 8. So that is these two, they are exactly the same. We formed an equation where we can solve for what? For x. Calculate the value of x, remember. So that is an equation. Solve for x. 0 minus 1, that's minus 1 over. There we're going to simply expand the bracket. Minus times x minus x times negative 5, negative 5. So 8 minus 5, that's 3 minus x. So we're going to have 3 minus x, which is equal to what? 2 minus 0, that's a 2 over what? 7 minus 8, that's going to be negative 1. So that is what we have. And from these two fractions, we can simply cross multiply so that we can determine the value of x. Negative 1 multiplying what? X minus 1. The 2 is going to multiply 3 minus x, right? So let's see. 2 into, all right, sorry. So that's 2 into what? 3 minus x. It is equal to minus 1 multiplying what? X minus 1. So that's 2 times 3. That is going to give us 6 times negative x minus 2x minus 1 times x times negative 1. That's a positive. It's going to change into a positive. So finding the value of x, we can take the minus x minus 2x. Minus x is going to change to a positive. So minus 2x plus x is what? Minus x. So that's minus x is equal to, taking the 6 to the other side, is going to be a negative. So 1 minus 6, which is what? Negative 5. So that's, we can have the value of what? The value of x. X is equal to what? X is equal to 5. So just like that, playing around your questions, you have got your x value, right? So that is the collinear concept, which you can work it in any way that you want. You can even consider A to C. You can consider any part that you want, guys. A to C, A to B, as long these points are on a straight line, they are going to give us the same gradient. So you calculate from that concept of the gradient. All right, so that was it, question number one. Let us move on to question number two. In this diagram that we are given, all right, we have got the points, all right, that are presented, all right, the point DE. M is the point such that DE, all right, or is a point on DE such that DM is half of DE, all right? DM is half of what? Of DE. So M is what? The midpoint. It is halfway. So that is the concept here. We are given this as the midpoint. And another concept that we are given here is that DMGO is a cyclic quadrilateral. So these 4 points or 4 vertices are to be on a what? On a circle like this. Remember the cyclic quadrilateral concept. So that is something like this. You're going to form what? A circle, passing through these 4 points, all right? The vertices that you're given. So that is what we are given. And from this, 2.1, write down the coordinates of what? Of M. Write down the coordinates of what? Of M. M is here, remember, it is the midpoint. So it is the midpoint of what? Of DE. So we can actually have the midpoint. M, simply take the X values together. All right, remember the midpoint concept, guys. X1 plus X2 over 2. Y1 plus Y2 over 2. That's the midpoint concept. So simply, we're going to take the X value, 0, and minus what? 0 and minus 12 divided by 2. Then the Y value, 6 and what? 6 and 0. 6 plus 0 over 2. So that was the coordinate M. Minus 12 over 2, that's minus 6. All right, 6 plus this divided by 2, that's a 3. Right, so that's it. The point M there is at negative 6, 3. Okay, no problem. Then another part, write down the size of DMG, the angle DMG, all right, this angle DMG, the angle that is being formed here, DMG, all right? Take note, this is a cyclic quadrilateral. So using our Euclidean geometry concept, we do understand that angle O, this one, DOG, is what? 90 degrees. We've got a vertical and horizontal line. They do meet at what? 90 degrees. And what about opposite angles of a cyclic quadrilateral? They are supplementary. So it follows that using that concept, we can find the angle what? The angle DM, they said what? DMG. So angle DMG is simply going to be 180 degrees minus 90 degrees. So that's 180 degrees minus 90 degrees minus angle DOG minus angle DOG. All right. Opposite angles of a cyclic quad are what? Supplementary. So that is going to give us what? 90 degrees. So that is it here. Opposite angles of what? Of a cyclic quad. They are supplementary. They add up to 180 degrees. So we can use that. So DOG, we've got a vertical and a horizontal line. So that one, we know that it is what? A right angle at what? 90 degrees. So that was the concept here. Then determine the equation, all right, of MG. The equation of what? MG. So remember, we've got the point M, but in this case, we do not have the point G, which is difficult for us to just say, all right, the point G is like this. All right. So what we can use is that, remember, M is what? 90 degrees, guys. This is at 90 degrees right angle. So meaning to say MG is perpendicular to to DE. These two lines are perpendicular. So we can use the concept of what? Perpendicular lines in that case, all right? So that's for our 2.3. We need to find the equation of MG, but MG is perpendicular to what? To DE, to the line DE. They meet at what? 90 degrees. They meet at 90 degrees. So what is the concept if two lines are perpendicular? The product of their gradients, the product of their gradients is supposed to give us what? -1. So we cannot determine the gradient of mg because we do not have the point g. We only have the point m. So we can take advantage of the point what? Of the line DE, because we have the point D and the point E. So from that, you can determine what? The gradient of DE. So from what? From DE, let us determine its gradient. Remember the gradient, guys, y2 minus y1 over what? x2 minus x1. So we're focusing with the DE. That's exactly all this. All right. So y2, that's 0 minus y1, 0 minus 6 over x2 minus 12 minus what? Minus x1, which is our x1, it's 0. So that was going to give us the gradient of what? The gradient of the line DE. And from your calculator, you were going to obtain 1 over 2. So using that gradient here, we can find the gradient of what? Of DG. The gradient of MG, the one that we need, it's what? Its equation. So we are simply going to use that concept. The gradient of the line MG times the gradient of the line DE that we are given, which it is perpendicular to, is supposed to give us a -1, the product of these two. So what is the gradient of what? Of the line MG? Simply divide by 1 over 2 or multiply by 1 over 2. So that was going to be a negative what? A -2 minus 1 over 1 over 2. All right, so that's -1 over what? 1 over 2. So this is it from your calculator, -2. So the gradient of the line that we need to find its equation, we have it. Remember, we're focusing with what? Finding the equation of what? The line MG. So therefore, y is equal to mx plus c, y is equal to m, the gradient of what? Of the line that we are supposed to calculate mg, which is what? -2. So that's -2x plus c. To find the value of c now, we have to focus with the what? Any of the points where this line passes. It passes through the point M and G. So we do not have the point G. Yes, we do not have that, but we have got what? The point M. This line passes through what? Through M. So we can use that point M here to what? To find the value of C's. All right, so from what? From point M, the Y value is what? Is 3, whereas the X value is what? The X value is a -6. All right, so that's it. We're going to have the value of C from there. So that is it. 3 is equal to 12 plus C. All right, so if I was going to take this to the other side, it was going to be a -3 minus 12, which is what? -9. So -9 is equal to C. Therefore, our equation was going to be from here, y is equal to -2x plus c. Our c is what? -9. So that's it. This is the equation of the line MG. MG is perpendicular to what? To DE. So if the two lines are perpendicular, the product of their gradients is -1. So you simply work with that one, then you are done. Right, then another part, it was to calculate the area of all right, not a triangle, but this shape. Right, let's focus on that shape DMGO. All right, D to M to G to O. All right, remember the cyclic chord concept, and you say this is 90 degrees. So we can actually determine the area D to O to this DM like this. This is the one that we want. All right. So what can we actually do, guys, to find this area? Remember, this is 90 degrees, and this is also 90 degrees from what we had before. So we can use a lot of concepts, actually. So many ways that you can play around. But what I'm gonna simply work with here is the bigger triangle is a right angle triangle, right angled at what? At O. All right. And this smaller triangle here, which is MGE, is also a right angle triangle, right angled at what? At M. So I can play around, calculate the area of the bigger triangle, then subtract the area of what? The smaller triangle. Or I can divide from D to G like this. Find area of this right angled triangle DOG, add it to the area of the right angled triangle DMG. You can do it that way. It is in your hands, all right? So as for me, I'm just going to work with the bigger triangle, then subtract the smaller triangle in that case. So that is going to give us, right? This is 2.1, right? Sorry for that. This is 2.4. So as for me, guys, to determine this area, I'm going to work with the bigger triangle, like I say, to find the area of they said what? DMGO. DMGO. From D to M to G to O. All right, so that is what we are given here. So as for me, like I said, I'm gonna work with the bigger triangle. So working with the bigger triangle, it is gonna be area of what? Area of triangle. I'm gonna use DOA, triangle DOA, minus area of this smaller triangle. That is area of triangle what? MGE. M to G to E, all right? So the first one, I can obtain its area, DOE, from D to O to E. We can have that area separately. We can determine that area triangle DOE. It is a right angle triangle, so it's going to be half of the base, which is OE, half of base times perpendicular height. That's half of the base, which is from O to what? From O to E times the perpendicular height, which is from O to D. So that is half of from O to E, that is horizontally the point from the origin up to the point E. We just take the X value at E, which is what? Which is positive 12. The distance you consider positive 12. It's a point at minus 12, but magnitude, all right? Then from O to D, you consider the Y value. This is a vertical, so the Y value is what? Is 6 there. So that is going to give us the area of the 6 times 6. That is what? 36 square units. Half of 6 in half of 12 is 6, then times 6. That is going to give us what? 36 square units. So we have the area of the first triangle DOE. So we need now to determine, just like what we had, the area of the smaller triangle MG to E, this smaller triangle. On this smaller triangle, we have the point M, the point E. We do not have the point G, right? Because what we are going to need if we were to determine that area, all right, let me just show you guys here what was actually gonna happen. You are going to consider here to say the area of the smaller triangle, which is M to G to E, using half base times perpendicular height. You can take M to E, this one, as your base. So it is half of ME times the perpendicular height from M to what? To G, the ones that meet at what? 90 degrees. So it's half of ME times what? MG. So ME, we can have the length of ME, all right? We never calculated that one, the length of ME, but we can determine the length of ME since we have the points M and E. But MG is limited because we do not have the point G. So what are we going to do? The point G can be determined from the equation of the line MG. Remember, we have the equation of the line MG. As G is what? The x-intercept, where y is equal to 0. We can find the point G from the equation of the line that we are given, which is what? From our line MG. To find that point D, we can use what? We can use this equation that we calculated before, that we determined. So that's the point D being the x-intercept. Y is equal to 0. So that's 0 is equal to minus 2x minus 9. Let us find the value of x. All right. Minus 2x is going to change into a positive. All right. So that's equal to negative 9 divided by 2 by 2. So x is minus 9 over 2, or minus what? 4,5 at point D, where D is what? Where D is the not at point, why am I saying D? At point G. G, not D, guys. At point G. Can we correct that? So therefore, the point G, since it is an x-intercept, that's minus 4,5 versus 0. Remember, the y value is 0. So for the point G, here the x-intercept, sorry, our x-intercept from the equation of the line that we calculated before, the equation of the line what? M to G. So this is it. So we can determine the area of this triangle if we can obtain the length of ME and what? MG, which we do not have. So that is why, guys, you see 6 marks there. It's a lot of calculations to be considered. So from here, we are going to need these two, M to E and what? M to G. All right, so let's calculate ME. We simply need the length from our length formula. We can just consider y2 minus y1 squared plus what? X2 minus x1 squared. Whatever that you want, we can even start with the x values. So M to G, M to E. Let's start with M to E. All right, so y value, that's 0 to what? To 3. So that's 0 minus 3 squared plus the x value minus 12 to what? Minus 6. Minus 12 minus 6 squared, like this. So that was going to give us the length of ME, all right? You're going to determine the length of ME from there. So this is the idea, guys. Just make sure you use your calculators properly. That was going to give us the square root of 45, which is what? 3 square root of 5 units if we simplify properly. So we do the same thing for M to G using the length formula, the square root of considering the y values. All right, starting the y values 0 and what? And 3 at M. So that's 0 minus 3 squared plus the x values minus 4,5 to what? To minus 6. Minus 4,5 minus 6 is squared, right? So make sure you use your calculators properly. That was going to give us the length, right, of what? Of mg. From your calculator, you're going to obtain something like this, the square root of open bracket 0 minus 3 plus, right? Sorry, you need to square this one plus minus 4,5 minus 6 squared is going to be 3 square root of 5 over 2. 3 square root of 5 over what? Over 2. So this is the length of what? Of MG, which we can use to determine the area of that triangle MGE. That's the length of M to E. M to E is what? 3 square root of 5. We calculated this. 3 square root of 5 times M to G. Remember, our M to G is what? 3 square root of 5 over 2. We calculated that. 3 square root of 5 over 2. You can even use your calculator to simplify or evaluate everything at once. So this is 3 square root of 5 times the fraction of 3 square root of 5 over what? Over 2. And that was going to give us 45 over 4 or 11,25 at the end. All right, so that is what we are going to have 11,25 square units as we are determining the area. So with these two areas, from what I'm having, the area of the bigger triangle minus the area of this smaller triangle, I'm going to remain with the shape that I'm being given here, DMGO. So that's it. The bigger triangle, we obtained 36 minus the smaller triangle, 11,25. So that was going to give us the area that we want, which is 24,75 square units. So we've got the area just like that for 6 marks. All right, so you see, guys, they are going to ask these typical questions, and you must be very careful. As long you can formulate a shape, work with a shape that is being formulated the way that you understand, all right, from the formulas, area of triangles, this and that, what you understand, work with that one. That's going to help you a lot. And also the distance formula, you must understand your distance formula in the application. All right. Let us see from here, we have got question number 3, where we are given 3.1. The tan of theta is 5/12, and our theta is supposed to be taken from 90 to 360 degrees. So from 90 degrees, remember that's 0, 90, 180, 270, what, 360 degrees. So from 90 to 360, we are considering the second, the third, and the fourth quadrant. Those are the two that you are to focus on. In these 3 quadrants that are remaining, where is it that our tan is a positive? As you can see, the tan of theta is 5/12. That's a positive. Where is tan positive? In the 3 remaining from the cast concept, but we are focusing with these three from 90 to 360 degrees, from 90 to 360 degrees. Where is tan positive? It is in the 3rd quadrant. So meaning to say, where they are saying with the aid of a sketch, your sketch is going to be what? In the 3rd quadrant, where tan is positive according to the angle that we are given. We are not going to focus with the 1st quadrant, but we are going to focus with what? With the 3rd quadrant. We are given a condition, guys, to work with. So using that 3rd quadrant, we are given the tan of theta. Remember from your SOHCAHTOA concept, tan is opposite over adjacent. So if this being our theta, this is our opposite, and this is our adjacent. So that's opposite over adjacent. And the opposite is the the y values. So it's just like y value over x value. So that's 5. Our adjacent is what? Is 12. But we know that on the left side, x is supposed to be what? Negative. So that's a negative 12. And the y values going down, they are supposed to be what? Negative. So that's a -5 and a -12. So without using a calculator, they want us to find the value of sine theta plus what? Cos theta. We know the quadrant where this is, and from that quadrant, we have formed a right angle triangle. So what can we find? We can find the hypotenuse r, so that it will be easier for us to find the given question, sine theta plus what? Cos theta. So we must find our hypotenuse r, the square root of what? X squared plus y squared. So our r was going to be the square root of x squared minus 12 squared plus what? The y minus 5 squared, which you can just use our calculator. That was going to give us square root of 169, which is 13 units. So from there, the magnitude, the hypotenuse, guys, is always what? Positive. So you consider the positive value. So therefore, the sine of theta plus the cos of theta that we are given here is equal to what? Sine opposite over hypotenuse. So according to this, our opposite, our hypotenuse is this. Remember, this is our adjacent and this is hypotenuse. So opposite over what? Hypotenuse. -5 over what? Over 13. Or simply the y value over what? Over the hypotenuse. All right? Plus the cos of theta adjacent over hypotenuse. So the adjacent, those are x values over hypotenuse. So the x value is what? -12 over what? Over 13. So that is it. We can combine this since the denominators are the same. Simply add what? The numerators together. So that's -5 plus minus 12, which is going to give us what? A negative. So minus 5 minus 12 is what? Minus 17. So that is what you're going to have as the cos of theta. That means the sine of theta plus cos of theta, just like that. We can evaluate without using a calculator. All right, same concept here on 3.2 where we are given, all right, sorry, let us consider, sorry for that, 3.2 here. So same concept, but this time we are given the cos of a certain angle is equal to K. And that angle is an acute angle, as you can see. So if we're going to consider that we have got a diagram here, then the cos of a certain value, which is 62 degrees, is equal to K. So this is same as what? K over 1, remember? Where cos from our SOHCAHTOA concept is what? Adjacent over the hypotenuse. So it simply means if this angle here is 62 degrees, the adjacent side over the hypotenuse is what we are given. Our adjacent is what? Is K. And our hypotenuse is what? Is 1. So we can find the third side, which is representing what? The y values. So remember from here that r squared is equal to what? X squared plus y squared, where r is the hypotenuse. 1 squared is equal to our x is what? Is k, so that's k squared plus y squared. 1 minus k squared is equal to y squared. So we're going to find what? We're going to find our y from there, making y the subject of the formula. So that is what? The square root of 1 minus k squared here. And with this, we can determine whatever that we are asked. It's very, very important that you do simplify the diagram first. And you can answer these typical questions that you're given. 3.21, the sine of 28 degrees. We can find it from the co-function concept, or we can simply use this triangle because we do understand that the angle here in a triangle, you're supposed to have 108 degrees. And these two are supposed to give us what? 90 degrees. So this remaining angle is simply 90 minus what? 62 degrees. And 90 minus 62 degrees is going to give us what? 28 degrees. So that is the angle that we are having there, the remaining angle. So that's the sine of 28 degrees can be obtained opposite over hypotenuse according to 28 degrees. This is our opposite and this is our hypotenuse. So it's opposite K over hypotenuse, which is 1. So that is equal to K, which is same as what? Cos 62 degrees. If you could have just use the co-function concept, still you're going to have the same answers there. All right. 3.2.2, the tan of what? 338, 328, 332 degrees. So let us try to use our reduction concept. The angle of 332 definitely is going to be in the fourth quadrant after 270. In the fourth quadrant, where angles are given as 360 minus theta. So can we try to reduce this one into that? So it's going to be tan 360 degrees minus theta. Remember, it's an acute angle, this one. We are dealing with an acute angle. So to find that angle, simply use 360 minus what? 332 degrees, which is what? 28. So it is the same as 360 minus 28. Where tan in this quadrant is what? It is a negative. It is the quadrant for cos. So tan and sine, they are negative. So it can be reduced into a negative tan of what? The acute angle. Negative tan theta. Negative tan what? 28 degrees. So that's it. Negative. What is the tan? From our SOHCAHTOA concept, opposite over hypotenuse. So according to 28 degrees, opposite. This is our opposite, which is K. Our hypotenuse is what? 1, the square root of 1 minus K squared. So that's opposite K over the hypotenuse, the square root of what? 1 minus K squared. So that was the angle. I mean, that was the tan of what? 332 degrees, just like that. You see, trigonometry is just one of the easiest. Is a follow up everything. You are not forming anything, guys. All these things have been mathematically proven. It's just following identities and every concept that you do understand, reduction concept, this and that. So, question number 4 on 4.1, calculate the value of the following expression without using a calculator. So also try to reduce where is possible the cos of 150 degrees. We know that is going to lie in the what? In the second quadrant. So that's in the second quadrant. These angles are written as 180 minus theta. So it was going to be the same as the cos of 180 degrees minus our theta being the acute angle. So 180 minus 150 is what? 180 minus 150 degrees is 30 degrees. So it is the same as cos 180 minus 30 to get 150. So where in this quadrant, cos is what? From the cast concept, cos is a negative. So that's negative cos of what? The acute angle. Cos theta, our theta is what? 30. So that's negative what? Negative cos 30 degrees times the tan of 300. 300 degrees is now in the what? Third quadrant. So that's where we're going to have in the fourth quadrant, 300 degrees. And in these angles is 360 minus theta. So we must write it as tan of 360 degrees minus what? To get 300, it is 60 degrees. 360 degrees minus x is equal to 300. So what is the value of x? That's what I'm trying to say. All right. So our x is going to be what? 60 degrees. But tan is what? Negative in this quadrant. Tan is negative. So that's negative tan of what? The acute angle, 60 degrees. So that's negative tan of what? 60 degrees over what? The sign of minus x from our negative angles. Minus x or minus theta is in the fourth quadrant, and that is the quadrant for cos. So sign is what? Negative there, right? Then we have got tan of 945. This angle is greater than 360 degrees. So we're going to subtract 360 degrees from that until we've got an angle below that. 360 from what? 945 subtract 360, that's 585. Again, subtract 360, that is going to be 225. 225 degrees is what? Is less than 360 degrees. So this is what we want. So we can play around with that. Same concept as what we've been doing, but where is it that, where do we find 225 in the third quadrant? And the third quadrant is for angles of what? 180 degrees plus theta. So it is supposed to give us the tan of 180 degrees plus what to get this? 180 degrees plus x is equal to 225. So what is our x? Simply subtract 225 minus 180. That was 45 degrees. So it is tan 180 degrees plus what? 45 degrees, our x here. So remember, in the third quadrant, it is the quadrant for tan. So tan there is what? Positive. So when you reduce it, it's going to be positive tan of what? The acute angle, tan 45. So this one was simply going to be tan 45 as it is positive. So we applied our reduction where it is possible. We reduced our angles, positive and negative angles. But remember, they said without using a calculator. So what can we do? We can use our special angles now to determine these angles. Since the calculator is not required, remember your special angles, guys. You're supposed to know these ones by head. All right, to memorize these triangles that you're going to have. 45, 45. This is 1 square root of 2. So that is it. From here, we can determine our angles. So this is the concept that you're going. So we can simply determine our angles in that manner. The cos of 30 degrees, remember from your SOHCAHTOA concept, adjacent over hypotenuse for cos. So 30 degrees, this is our adjacent and hypotenuse. So that's square root of 3. There's a negative here. Negative square root of 3 over hypotenuse, which is what? Which is 2 times the tan of minus tan 60. Tan 60 opposite over adjacent according to 60 degrees. This is our opposite and this is our adjacent, which is 1. So square root of 3 over 1, everything over negative sine 30 opposite over hypotenuse. So according to this is our opposite. This is our hypotenuse 1 over 2 or negative 1 over 2 times the tan of 45 degrees opposite over adjacent, guys, is going to give us 1 over 1, which is what? Which is 1. So there we had to use our special angles in order for us to determine these angles, then simplify. All right, so the numerator negative negative cancels. Square root of 3 times square root of 3 gives us a 3. Remember, square root of a times square root of a is a from our sets. So it was going to give us 3 over what? 2 times 1, that's a 2. All right, everything over what? Negative half times 1, that's a negative half. So this is going to give us 3 over 2 times, you interchange the second fraction. So it's 2 over negative 1, which is 3 over minus 1 is what? A negative 3 at the end. All right, so this was going to give us a negative 3 at the end. All right, so it's just about revision, more revision, guys. Just do revise as many questions as you can. All right, so that was it from here. We have got 4.2, simplify this expression. All right, so we are supposed to simplify until we have a single trigonometric ratio, a single trigonometric ratio, whether it is just a sine, whether it is a cos, whether it is a tan, a single, not to have sine, cos, and we just have one, whether it is cos, whether it can be cos squared, it can be what, but as long as it's a cos or a tan or a sine. So what can we do? We need to reduce, guys. This part of our reduction. All right, but 450 on the first part here is greater than what? Greater than 360 degrees. So we have to subtract it from, we have to subtract 360 from what? 450. So that is going to be 90 degrees. So it is the same as the sine of 90 degrees minus x. All right, the sine of 450 degrees minus x is the same as the sine of 90 degrees minus x, which is the same as what? As the cos of x. From what? This is from our co-function concept, all right? So it's going to give us the cos of x times cos of minus x from our reduction. Minus x is in the fourth quadrant, and that is for cos from our cast concept, negative x. So cos there is what? Is positive. So you write it as positive what? As positive ratio. The sine of 360 degrees minus x, it's also in the fourth quadrant. 360 degrees minus x is a positive angle. Minus x is a negative angle. They are both found in the what? In the fourth quadrant. But in the fourth quadrant, sine is what? A negative. So this sine was going to be a negative ratio, negative sine of the acute angle, sine of x, times the cos of 90 degrees plus x from our co-function. But when cos is having 90 degrees plus x, it means that cos is gonna fall in the what? In the second quadrant, 90 plus x. And in the second quadrant, it is a negative. Cos is a negative in the second quadrant. So therefore, it is going to be negative from our co-function, cos changes to a sine. So it's a negative of the sine of x. All right, that is the concept. So cos is negative, but being a negative of what? Of another function, co-function. All right, cos times cos, that's going to be cos squared of x over what? Negative, negative cancels, sine times sine, that is what? The sine squared of x. But they say a single ratio, a single trigonometric ratio. There we have got two trigonometric ratios, cos and a sine. So how can we write them in a single? Cos and a sine, they are from a tan. The tan of x is sine of x over cos of x. So its reciprocal, 1 over tan, is simply interchanging this is going to be cos of x over the sine of x. So understanding that when we have got a cos squared over a sine squared is simply from what? The reciprocal of a tan. But this one will be what? Tan squared, since both are being what? Squared. That's a single trigonometric ratio that we are having at the end, a tan. Not this one. No, 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 no. That one, there are two, cos and a sine. Ratio there. The ratio of a cos, the ratio of a sine. We are supposed to have just a sin. So this one is what? A tan. So that was it on 4.2 for 5 marks. All right. Then let us consider 4.3. Given this identity, all right, from this identity 4.31, we are supposed to prove it. Prove the above identity. So I'm just going to focus with the left-hand side where it is much complicated. The left-hand side is equal to tan, the tan squared of x minus the sine squared of x, all right, into 1 plus the cos squared of x over what? The sine squared of x. All right, remember that we can actually play around when we're working with this one, we can play around, change a tan to a cos. Remember, from what I just explained, tan of x is sine of what? Sine of x over the cos of x. But this is being squared. So we're just going to write this as the sine of squared x over the cos of squared x, like that. All right, minus what? The sine squared of x. All right, let's see. Then here 1 can be written as sine squared as the denominator. So we can write it as sine squared of x over what? Sine squared of x, so that we can add properly. The denominators will be simply the same. We haven't changed anything, just for addition purposes, right? So let us add here. The sine squared is same as like sine squared of x over 1. So thus, we are going to have the LCD of the denominators as what? The cos squared of x. So divide cos squared and cos squared, that's a 1 times sine squared. So that's the sine squared of x minus cos squared and 1, that's a cos squared, times the sine squared. So it was going to be sine squared x times what? Cos squared x. All right, so this is what you're going to have. And here, since we've got the same denominators, just maintain that denominator and add the numerators together. So we're just going to add the sine squared of x plus what? The cos squared of x. All right, so we can see that something is familiar somehow. In the numerator of the first fraction, the sine squared of x is common. So you can factor out the sine squared of x. So we're going to have 1, this one, and this one is going to cancel. You remain with what? The cos squared of x over what? Over cos squared of x, all right? Times, there we can multiply here. Sine squared plus sine squared, this is our Pythagorean identity, which equates to 1. So it is the same as a 1 over what? Since we have got a sine squared here, we can just rewrite this one as a sine squared so that these two can what? Cancel. Numerator, denominator concept. So what am I left with here? Left with, all right, 1 minus cos squared, 1 minus cos squared of x over what? The cos squared of x. Remember, from our Pythagorean identity, cos squared x plus the sine squared of x, which gives us a 1. 1 minus cos squared was simply obtained when we are having what? The sine squared of x. It is the one that is equivalent to 1 minus cos squared. So meaning to say, it is the same From that, I can write it as a what? As a sine squared of x over what? Over a cos squared. Why writing it as a sine? Remember, sine over cos gives us a tan. So therefore, it was going to be a tan squared of x, which is exactly what you are having on the what? On the right-hand side, tan squared of x. So there are actually so many ways of proving this, so many ways that we can actually prove this typical part. So just try to also go through the memo, the marking guideline, and see how they answer these typical questions in terms of other ways of proving this. All right, then 4.3.2. Calculate the values of x in the interval from 0 to 270 for which the above identity is undefined. So instead, we can use that what we have already on the right-hand side, a single what? A single trig that we have already proved. So from that single trig that we proved, which is the tan squared, how can we prove that this is what is undefined from the given interval, all right? From the given interval, how can we improve from our x being taken, let's say from 0 to what, 270 degrees. When this is undefined, we focus with the denominator, guys, all right? The tan squared of x, remember, it is the same as what? Sine squared x over the cos squared of x. So you work with the final answer. Then the denominator is the one that you work with. For it to be undefined, it must be what? Equal to 0. Remember, k over 0 is what? Undefined. We cannot simplify that. So the denominator has to be equal to 0, just like that. So introducing the square root to get rid of this square, it is going to be the cos of what? The cos of x. The cos of x is equal to 0. So remember, cos of 0, guys, these are direct angles where x is going to be the arc cos of 0, which is what? Shift cos 0, which is what? 90 degrees. So actually for cos, you are limited where cos is going to be 0, like in terms of the graph, all right? Cos of x from that part, arc cos of what? Arc cos of 0 is what? Is 90 degrees. So that is where we have got here, it is going to be here 90. That's, remember, this is 0, 90, 180, and what? 270 and 360 degrees. So 270 is also where cos is what? Where cos is at 0. So 270 can also work. The cos of 270 degrees is what? Is a 0. So meaning to say, therefore, our x can be what? 90 degrees, or what? X is equal to 270 degrees. So you take from the final answer that you have proved from the tan of x. So you work with the denominator, which is the cos, not sine. So if you check the memo, they just made an error using the sine of x. You must work with the cos of x, all right? The denominator from the final answer, all right? So that was it on that part. Then 4.3, we are asked to determine the general solution of this, all right? So if you have to consider here, there's a lot, 7 marks, all right? So let us see how can we attempt this. That's our 4.4. We have a denominator, so let us have these ones as fractions here. So because of this fraction, this is same as over 1. So we're going to consider the LCD of the denominators, which is the cos of x multiplied by cos of x multiplied by cos of x multiplied by cos of x by cos of x, each and every term. So that was going to be 5 cos x times cos x, which is what? 5 cos squared x, all right, minus 5 sine x times cos, which is 5 sine x cos of x. Cos and cos was going to cancel, so that's -2 equal to 0 times any number, that's a 0. So here, guys, you can see that the middle term, it has sine and cos. raised to the exponent of 1. These are linear terms, and it's very difficult for us to rewrite a cos as a sine or a sine as a cos for a linear. It is easier when it is a cos squared, because we can say, all right, a cos squared, we can take what? 1 minus what? Sine squared of x. But if we are going to take that 1 minus sine squared x, we're going to be limited because we'll be having a sine, and you're going to have a sine x and a cos x again here, so you'll be limited. So what can we do? Because we have a linear, this part is linear, and there are two terms, cos and a sine. We must introduce a sine. What we need is to have an expression like this, 5, something like where we have got x squared, xy. This must be something of y. Like if this is y squared and this is x squared, then these two terms will be of x and y. Yes, we can have any other number in it, but I'm focusing for us to have xy here, we must have a square of x and a square of a y. So in order for us to have sine x and cos x, we must have a square of a cos and a square of a sine, just like x and y. So we must introduce a square of a sine. So where can we have that? And we already have a square of a cos. So we can introduce both. Remember, cos squared of x plus the sine squared of x gives us a 1. So introducing a 1 does not affect our question. If we say minus 2 times 1, it does not affect our question. We haven't changed anything. But 1 is same as what? Cos squared plus sine squared, where we are introducing that sine squared together with a cos. I want you to see what we're going to have here. If we introduce that, so that we can have what? A cos squared and a sine squared. So this will be equal to what? This will be equal to 0 as part of our equation. So in place of that -2, we're going to multiply it by 1. Multiplying it by 1 does not affect our question. But what we want is to introduce a square of a cos and a square of a sine, so that we can formulate something like this that we are used to. So from there, this is what you're going to have. 5 cos squared of x minus 5 sine x cos of x multiplied by -2. That's going to be -2 cos, all right, cos squared of x, -2 times sine, -2 sine squared of x equal to 0. So collecting the like terms, we've got a cos squared and a cos squared here. So 5 minus 2, that's going to be 3 cos squared x minus 5 sine x cos x. All right, so this is what we are going to have. Then this one, minus 2 what? Sine squared of x is equal to 0. So as we can see, we have the format of the equation that I was trying to explain of this expression, where we have xy in the middle, then it means the boundaries are supposed to be the squares of x and y, the boundaries. So having x and y, cos and a sine and a cos, linear like this, they are linear terms, these ones. So it means their boundaries are supposed to be what? A sine and a cos, like what we have here, a cos squared and a sine squared. Those are the boundaries of that expression, which will be easier for you to factorize. If you can factorize something like this, let's say your x is represented by cos of x, then y is represented by sine of x. It means this was going to be written as 3x squared minus 5. All right. Remember sine x here, writing sine x or cos x, sine x. Here it is just the same. So here it is same as minus 5xy minus sine is represented by what? By y. So that's minus 2y squared. Can you factorize such type of an expression? Yes. You can factorize. If you can factorize this, then you can also factorize this as well. But if you do not understand from this, then factorize it as a normal algebraic expression that you are used to. All right. So factorize. Remember your cheat method. You can multiply this to get rid so that we have got 1 here. So multiply by 3. That will be x squared minus 5xy minus 3 times 2. That's negative 6y squared. Then we're going to have two brackets from x. This is x. Then we need what? Minus y squared, the constant that you're going to multiply. Two terms that you multiply to get minus 6y squared. But when you add them, you must get what? Minus 5y, this one, minus 5y. So that's minus 6y and y. Multiply this, minus 6y squared, add minus 5y. So these are what? The terms. Minus 6, sorry, minus 6y plus what? Plus y, like that. Do not forget the 3 that we cheated with. It must what? Be used back. Sorry for that. We take that back. We take that 3 back in place of x. So we're going to put a 3, put a 3. Factorize where possible. 3 is common here. So that's going to be x minus 2y. All right. So factoring out our x. Then this bracket, we do not have anything common. So it is just going to remain as it is. Remember, this is useless, not required. So therefore, from this, x, remember, it represents cos. So this is cos x. This is sine of x. So it's going to be cos of x minus 2 sine x into what? 3x cos x sine x. So it's 3 cos x plus what? Sine x equal to 0. That's it. If you can factorize this, you're done. As long you can factorize that, you're done. Then you consider your brackets, this and that, from what you are forming. All right. Remember, we're gonna need the general solution, but for now, we have to simplify and see the single trig that can be formulated, a single trigonometry that we can form. So the two brackets equal to 0, one has to be equal to what? 0. Or the other one has to be equal to 0. So that's it from here. We're going to take this to the other side. It's going to be positive. Cos x is equal to 2 sine of x. So it is easier for you to make a tan where there's a sine and a cos. Remember, it is simply sine over what? Cos. So to obtain that, divide by cos. Divide by cos. So this is going to be 1 is equal to 2 sine over what? Over cos, that's a tan. So we are going to form a trig, an equation of a tan here. The tan of x being equal to what? 1 over 2. All right. Another one, you do the same thing. We can take the sine to the other side. It's going to be a negative. So 3 cos x is equal to negative sine of x. So to have that cos, the tan, sine over cos. So divide by what? By cos here, by cos here. So that's 3 is equal to what? Negative tan. This is negative what? Negative tan x. Negative tan x. So divide by a negative. That's tan x is equal to what? If we are to divide by a negative, that's negative what? Negative 3. So as we can see, guys, after all this simplification, we are ending up with what? A tan from all this that we had. We are ending up with a tan. So remember the general solution when you are working with what? A tan of x. X is equal to, you're going to consider what? The quadrant condition here. The condition of the quadrant plus 180 degrees times k. All right, so that is it. You have to consider the what? The quadrant condition. So let us start with tan of x being equal to 1 over 2. It's a positive. Where is it that tan is a positive? That is the quadrant condition where tan is what? Where tan is a positive. Tan is a positive in the first and in the third quadrant. So we consider the reference angle, which is what? Arctan, shift tan of what? 1 over 2. So our reference angle was going to be what? Let us consider the shift tan, arctan of 1 over 2. That was 26,573 to 2 decimal places, 26,57. So we're going to have 26,57 degrees. So using the quadrant condition, we can have the first one where we are considering all, this is where you've got the reference angle as it is. So x was going to be 26,57 plus 180 degrees times what? Times k. Or the second one in the third quadrant. And in the third quadrant, these angles, they are given as what? Where tan is what? Where tan is positive, these angles are given as 180 degrees plus what? Plus theta. Where theta is the reference angle, or 180 degrees plus what? The reference angle. So you're going to add 180 degrees plus what? The reference angle in that case. We're supposed to add the two. 180 degrees plus what? 26,57, which was going to give us 206. So that's x is equal to 206,57. So it's going to be 206,57 plus 180 degrees times k. So this is the condition where k is part of what? Your integers. So that is for tan of x, which is what? Which is a positive value, where tan is positive in the first and in the third quadrant. So you do the same thing from this condition. We're going to need the quadrant condition for what? This tan of x being a -3. This is a negative. Where tan is what? Where tan is negative. Tan is negative in the second and in the third. Where in the second is 180 minus the reference angle. And the fourth, which is 360 degrees minus what? The reference angle. So we're going to need the reference angle, where the reference angle is simply arctan of what? Arctan of the magnitude of this, arctan of 3, the magnitude. So that's our reference angle, just like the previous case that we had. You were going to determine the reference angle from there. And that was going to give us 71,57 degrees. So with this reference angle, guys, it follows that we can find our x values for that x, which is what? Which I mean for that tan, which is a negative. The first one, the quadrant angle, 180 minus what? 180 minus reference angle, 71,57. So you have to consider what? The reference angle for that one, which is what? 180 minus reference angle. So it's going to be 108,43 plus 180 degrees times what? Times k. Or your x is going to be another quadrant where tan is negative, is in the fourth quadrant of 360 minus what? Reference angle. Our reference angle is what? 71,57. So that was going to give us 288,43 degrees. So that's another solution that you're going to have, 288,43 degrees plus what? 180 degrees times k. So those are the conditions representing our general solution, and this k being what? Being an integer. So it's just a matter of playing around, guys, knowing your quadrant, where that is the quadrant condition. You must know where exactly the tan is positive or negative. But you look, guys, with 7 marks, this was not fair, guys. A lot of calculations, a lot of substitutions were being made and simplifications before you can even consider the general solution. You see, guys, that this part, it was just a lot for 7 marks. It's supposed to be something more than that. All right, but anyways, that is what we had. That is what we had. You see, it is part of your examinations, meaning to say sometimes they can give us more complex questions where you need to understand what you're working with, extend your understanding, extend your knowledge in terms of answering these question papers. You see, guys, it has to be something like that. So all these revisions, they are very, very important. Consider according to your syllabus, but do revise, all right, all these typical exam questions. And this is your continuation that you're going to have in your grade 12 mathematics. It is just like this. So as long you know your grade 11, you know that you are safe in grade 12 because it's just about revision. So you need to consider more question papers, guys, more question papers. So considering question number 5, we are given 5.1. In the diagram below, O is the center of the circle passing through A. So it is, all right, so O is the center of the circle, then passing through A, B, and C. So we've got A, B, and C. And we are given the chords AB and AC. So AB is a chord, AC is also a chord, and the radii OB and what? OC. From this concept, they are simply asking us here using, all right, the diagram sheet provided to prove the theorem that states that the angle subtended by an arc at the center of a circle, all right, an arc which is BC is going to subtend an angle at the center of the circle is double the angle subtended by the same arc, but this arc is subtending it at the circle, at the circumference. So the angle is double. That is BOC is twice angle A. All right. So let us prove, guys. We've already talked about these theorems and the proofs. So in order for you to prove this one, what you can simply do is to start up with some constructions. All right. Let us draw a line to join A and O. All right. So we're just gonna join A to O. All right, we're gonna start with what? Constructions. Join this point A to O, then extend that line to a certain point where you can even call it, since we've got A, B, C, we can call this one D. All right, so you join that A to O. All right, and from that, what we are going to introduce, remember, guys, we talked about this before, that from O to A, there is a radius, and from O to B, there is a radius. So we can introduce angle at A, which is BOA, I mean BAO, or OA to B, or BAD, the way that you want to call it, all right, as what? As angle X. We can introduce that one. So we can let that angle BAO from B to A to O to be equal to angle X. So from that, it therefore follows that the angle at B here is going to be X. Remember, from equal sides, the angles that are opposite, they are supposed to be what? They are supposed to be equal from the radii concept. So therefore, the angle OBA, angle OBA is also going to be equal to X degrees. All right, angles that are opposite what? Equal sides. So these are angles opposite what? Equal sides. All right, from the radii concept, these two, they are equal. So angles opposite, they must be equal. All right, so from that, we can obtain, remember our focus is here at BOC. So we can find BOD, where BOD, this one is the exterior triangle of triangle BAO. It is the exterior angle, and we do understand that the exterior angle is equal to what? The sum of the opposite interior angles. So X plus X. So we can use that concept, all right, to find what? Angle BOD. So angle BOD is going to be X plus X, which is what? Which is 2x. That's we are considering the exterior angle of a triangle, right? Exterior angle of a triangle, you know, that is equal to the sum of the opposite interior. So this is what you are also going to do on the second condition, working from this side, you can do the same thing, but introduce using another letter. So just like what we had on B or A, we are going to work with the C to O, to A to O like that. This angle, we can call it Y like that. So we can let CAO be equal to what? Be equal to Y. So using the same concept as before, it follows that this angle C is going to be equal to Y as these two are equal from O to A, from O to C. So opposite angles from what? Those equal sides. So guys, it's just going to be one and the same thing just like before. So that's we're going to have from that angle, therefore, from O to C to A, O to C to A is going to be equal to Y. All right, so same reason as what we had there. So therefore, this angle DOC is going to be what? 2Y, just like 2X before. So DOC is going to be Y plus Y, which is what? Which is 2Y. So that is similar to what we had before. So therefore, what we can tell from these two is that the angle that we want, which is BOC, BOC is the sum of these two angles. So we can add them, the 2x representing BOD and what? The 2y representing what? DOC. So that is it. Remember, angle A, we want to prove that it is twice angle A, where angle A, we know that angle A is given as what? X plus Y from what we introduced. So it's X plus Y. We already have X and Y, but where can we have the 2? The 2 is here, the common number, so we can factor that and have what? X plus Y like this. So it simply means X plus Y representing what? Angle A. So this is 2 times what? 2 times angle A. So that's our angle BOC. This is what they wanted you to prove, that these two, that the theorem that we have angle at the center is twice angle at the circumference. The angle at the center is twice the angle at the circle at the circumference. All right. So that was the first part of this question number 5. Then 5.2, there is a diagram that we are given below, and DF, right? DF is given as what? As the diameter of the circle center on. So the moment you are given a diameter, we know theorems governing a diameter, that a diameter subtends an angle of 90 degrees at the what? At the circumference. So we know that angle E is going to be what? 90 degrees. If we are given a diameter, it creates an angle of 90 degrees, all right? So we are then given these chords, and they intersect at H, and DF is perpendicular to EG. All right, from D to F and from E to G, it is perpendicular. That's the 90 degrees that we are given here at what? At H. All right, that's at 90 degrees. And the radius is also given. Angle EGF is 55. All right, EGF is 55. That's the only angle that we are given. And the 90 degrees here that, that we had before. So with this information, we just gonna try and answer our questions, guys, and see what we are given. They are saying what we are supposed to do is to calculate on 5.21, calculate with reasons the size of the following angles. A, angle D with the reasons, all right? So angle D, all right? How can we calculate? How can we determine angle D? All right, so in this case, angle D, if we are to consider, guys, it is the same as angle G. From the chord EF or the arc EF, it subtends angle at G. It also subtends angle at D. It creates angle at G and angle at what? At D. So meaning to say, angle D is simply the same as what? As angle G. Sorry for that. Angle D is simply the same as angle G. which is 55 degrees. These angles, they are subtended by the same chord, or they are angles in the same segment. All right, so we can just say in the short angles in the same segment. All right, angles in the same segment. You can have it that way. All right, so that was first part A. Then B, angle O2. All right, angle O2. So that's our B. We need to calculate angle O2. So we have the center. O is the center. Remember, there is O1 and O2. All right, O2 is angle at the center. From this chord, it is creating angle at the center, O2. It is also creating angle G. Remember from the previous theorem that we just proved, angle at the center is twice angle at the circumference. So meaning to say, angle O2 is twice angle G or angle D, whatever that you want to use there. So that was direct. Angle O2 is equal to twice angle G, 2 times angle G. That's angle at the what? Thus we are referring to angle at the center equal to angle at the circumference. So that is angle at center is equal to 2 times what? 2 times angle at the circumference. Angle at what? At circumference. Circumference like that, all right? So that is angle G. We have it 2 times what? 55 degrees, which is 110 degrees. So that was it. And 5.21 on part C, angle E3, all right? Angle E3. So remember here we have got 55 degrees, 110 degrees. All right, then let's determine angle E3. All right, so let us try to figure out angle E3. This is where we have got E, and this is our angle E3 here. So what can we actually use? Remember, the whole angle here is what? 90 degrees. D, E, F, we talked about angles in a what? Angles in a semicircle, angles subtended by what? A diameter. All right. And we also have from this, all right. Okay, we're just gonna try to figure out about this triangle. All right. Angle A3, we're going to need angle F1. So where can you obtain angle F1? All right. If this whole angle is 90 degrees, all right. If this whole angle E, all right. If the whole angle E is equal to what? 90 degrees. That is angles in a what? Angle in a semicircle or in the semicircle. Semicircle. If that whole angle is what? 90 degrees. It follows that we can calculate angle F1 from triangle DFE, all right? So find angle F1 from triangle EDF. EDF. Angle F1 is going to be 180 degrees. All right, instead of using 180 degrees minus this, we can simply say 90, since this whole angle is 90 degrees. So angle D and F1 add up to 90 degrees. So simply 90 degrees minus what? 55 degrees. Yes, you can use angles in a triangle, 180 degrees. You subtract 55 degrees. You also subtract what? The 90 degrees angles in a triangle. Still, you're going to have the same answer. So that was going to give us 35 degrees. That's we're talking about sum of angles in a triangle, right? Sum of angles in a triangle. So that is going to give us what? Angle F1. So if angle F1 is 35 degrees, guys, are we seeing, guys? It's going to be easier for us to find the angle E3, the one that we are being told from what? From triangle EOF. From this triangle EOF, you can find angle E3. All right, angle E3 is going to be 180 degrees minus these two angles, 110 degrees inside the triangle and 35 degrees. So that is going to give us angle E3. All right. So that was the concept in this case, because we are simply considering what angles in a triangle, angles, sum of angles, actually a sum of angles in a what? In a triangle. So that was the concept. Or you can use other ways, so many ways that you can actually use, guys, as long it is a theorem. That is what matters, as long it is a theorem that you are using there. So that was going to be 35 degrees. All right. So this angle is 35 degrees. Or another way that we could have just used here is that if this angle is 35 degrees, remember from O to F, it is the same as from O to E. So therefore, angle E3 is equal to angle F1, which is 35 degrees. The reason that you're going to use is that these angles are opposite what? Opposite equal sides. So you're talking about angles what? Angles opposite equal what? Angles opposite equal sides. Another way that we could have just found our angle E3 direct from angle F1. So you see, guys, it's all about a theorem. As long you are using a theorem, you can answer these typical questions, all right? Let us consider another part. We have got angle D, part D, which is angle E2, all right? Angle E2, this is where we've got our angle E2, all right? So let's try to figure out what can we use to find that angle E2, all right? So that's our part D. So let us figure out, guys, all right? No problem. That's E2, all right? Part D. Angle E2. So to find angle E2, we can play around our angles that we have. All right. This is all right. We can play around with from triangle. This we can use this triangle. That's where E2 is. We can use triangle EHO, triangle EHO. So from triangle EHO, we can see that we can find angle O1. It's gonna be angles on a straight line. So we can find angle O1, which is 180 degrees minus what? 110 degrees. So it's gonna be equal to 70 degrees. So that's 70 degrees. We are talking about here angles on a straight line, all right? Angles on a what? On a straight line, all right? I'm just gonna write this one in short. So if this angle is 70 degrees, find angle H1, H2, this one, inside the triangle. Angle H2 is equal to angle H1, 90 degrees, is equal to angle H3. Remember, we are told that this one is at 90 degrees. So also, guys, we know that these are angles on a straight line, or simply adjacent angles on a line, or angles on a straight line to H3, because H3 is given as what? 90 degrees. So it is simple. 180 minus 90. So guys, whatever that you wanted to give as a reason, you can have this one as a reason, angles on a straight what? On a straight line, just like what we had before. So if angle H2 is 90 degrees, guys, we can find angle what? Angle E2, because we are now talking about angles in a triangle. So it can be 180 degrees minus what? O1 and what? And H2. 70 degrees plus what? 90 degrees. We subtract O1 and what? And H2. So we're talking about what? Sum of angles in a what? In a triangle. So that was going to give us 20 degrees at the end. So angle E2 is what? Is 20 degrees. All right. So many reasons, guys. As long you've got a theorem that can be used or applied, please do that. You're going to see that it's just one and the same thing. All right. So that was it. Let us consider 5.2.2. It is further given that the diameter of the circle is 10 units, and all right, GE is 8 units. Calculate the length of OH. All right, the diameter is 10 units, the whole diameter. That's here. All right, let's try to erase one or two. So the whole diameter here, that's is what 10 units, and also G to E is 8 units. From G to E, the whole part of GE, the whole part of GE is what is 8 units. Then find the length of OH. Find the length of O to H. All right, let's try to figure out what's happening here. Let's try to figure out 5.2.2. We need to find the length of OH. OH from O to H. Okay, so since the diameter is given, we are told that the diameter is what? The diameter here is 10. So it means half of the diameter is what? Half of the diameter is radius. Radius is going to be 10 over 2, which is what? 5 units. So from O to F, it is 5 units. From O to E, it is 5 units. All right, that's the diameter concept. From O to D, it is also 5 units from the diameter concept. All right, then what else do we have? We are given here the whole E to H. That's E, GE, GE, not H. From G to E, the whole part is what? 8 units from G to E. But remember that this here is a diameter, or we consider the radius concept where a radius and a chord meet, or a diameter. We know that when you have got a chord and a diameter passes through that, it's going to bisect it into two. So that's from the chord concept, it's going to bisect. So from H to G, from H to E, it is the same. So meaning to say it's going to be 4 units, half of 8, which is 4, 4. All right. So you can calculate OH because what is remaining is a right angled triangle. All right. So that was it, guys. So this one was going to be easier. All right. So let me explain it from what I'm seeing here. We said we can find O to E. From O to E, it is going to be what? 5 units. Half of what? Half of 10. That's a radius. So remember, that's diameter is equal to what? Diameter is equal to 2 times what? 2 times the radius. So that's from O to E is going to be what? Half. All right. Then we also talked about from H to E. From H to E, it is going to be half of 8, which is what? 4 units. All right, half of 8. The reason being what is the line from what? Line from the center to perpendicular to a chord, all right? When it is perpendicular to a chord like this, it's going to be bisected at what is going to be at 90 degrees and by bisected. So that is the concept, that is line from what? From center. Line from center, I'm just going to write in short, perpendicular to chord. When it is perpendicular to the chord, it's going to bisect it into two, that is to divide it into two equal parts to bisect that line. So we are remaining with a right angled triangle. Remember before, guys, on our calculations, we said H2 is what? 90 degrees. So this is where we've got our H2, which is 90 degrees. And this is our point E and our point O. From O to H, this is the one that we need. But we have O to E, which is 5 units. We have E to H or H to E, which is what? 4 units. So you can use our Pythagoras theorem to find what? To find the length of OH. From our Pythagoras theorem, OE squared, our hypotenuse, is equal to the square of the shorter sides, H E squared plus OH or HO squared, the one that we need to calculate. So that's from our Pythagoras. You can play around your Pythagoras here. We have from O to E, which is 5, from H to E, that is 4, and the OH is the one that we are supposed to calculate. So you see how to play around with these questions, guys. You can play around your theorems, and that's it. 25 is equal to 16 plus OH, that's the squared here, OH squared. So take the 16 to the other side. It was going to be a negative 25 minus 16, that's a 9, and that's equal to OH squared. So we can find our OH by introducing the square root. So that's our OH was going to be what? 3 units from solving this part of our Pythagoras theorem. All right, so that is the concept. That is the concept. You could have played around it that way. Like I said, so many ways. This is maths, guys. So many ways that you can actually use in answering these typical questions. Then that was it. Question number 6, given this diagram, 6.1, we've got a cyclic quadrilateral, which is A, B, C, D, A, B, C, D, and their chords which are equal from A to C, from D to E. Remember, from these equal chords, angles opposite will be equal. So angle A1 is going to be equal to angle D. All right, then we have got a tangent. AH is a tangent from A to H. Remember, a tangent and a chord, angle between a tangent and a chord is equal to the angle that that chord forms in the other segment. So this angle is formed at what? At C2 is the same as angle A3 from that tangent. It is also the same as angle D2. All right. So that's what we can see from there. Then the straight lines are given. So from here, we are given it's the reasons actually on 6.11. Give reasons why angle B1 is equal to angle A1. We are already told that angle B1 is equal to what? Angle A1. Angle B1 here and angle A1, these two, they are equal. We are already told that they are equal. The reason being what? They are in the same segment. These are angles in the same segment. They are equal, or angles subtended by the same chord. So we can see that B1 and A1 are subtended by the chord DC. It creates angle B. It also creates angle A1. Angles subtended by the same chord or angles in the same segment. Angles in the same what? In the same segment. They are what? They are equal. Then another one, it was to 6.12, prove that A angle B1 is equal to angle ADC, all right, for 2 marks. So that's it. Angle B1 is equal to ADC. How can we prove this? How can we prove this? Angle B1, this is our angle B1 here. So angle B1, we already know that it is equal to angle A1, but they want us to prove that it is equal to what? ADC. Guys, I already talked about this. Remember, I said angle D and what? And angle A1, they are equal from what? From the sides which are equal, from these chords which are equal, angles what? That are opposite, equal sides. So angle A1 is the same as what? It is the same as angle ADC. So that's angle A1. It is the same. So this is what we need to prove. But angle A1 and angle ADC, they are equal because of what? They are angles opposite what? Equal sides. angles opposite equal sides. I talked about these guys, all right? Angles opposite what? Equal sides. But before we said angle B1 is equal to what? Angle ADC. We already talked about that. That angle B1 is equal to what? So hey, guys, what is happening here? Before here, we talked about something here about angle B1 and angle A1. Before we already proved that angle that angle B1 is equal to what? To angle A1 from these angles in the same segment. So already we proved this from that theorem that we talked about. So if A1 is equal to B1 and the same A1 is equal to what? ADC. So it means B1 is equal to what? ADC. So therefore, angle B1, the one that we want to prove, it is what? The same as angle ADC. So that is the concept that you just needed. All right, let us see another part. That is B1 is equal to B2 on part B. All right, so on part B, we need to prove that angle B1 is equal to angle B2. We need to prove this. All right, angle B1 and B2, this one, they're equal. All right. What can we do to prove that these two are equal? All right. We can prove from B2. If we can do this, guys, angle B2 and this angle ADC. Remember, we talked about angle ADC before. So that's this angle B2 and ADC. They are the same. Remember, that's ADCB like this is a cyclic quadrilateral. So angle B2 is the exterior angle of a cyclic quad. It is equal to what? Opposite interior angle. Angle B2 is equal to ADC. Angle ADC from a cyclic quad. That's the exterior angle of what? Exterior angle of a cyclic quad. Of a cyclic what? Quadrilateral. But before we talked about ADC being equal to what? Being equal to AB1. We proved that one before. That angle what? B1 is equal to what? ADC. From what we talked about, we already proved this before. So if B1, guys, if B1 is equal to ADC, but the same ADC is equal to B2. So therefore, B1 and what? And B2, they are the same. Angle B1 is equal to angle B2, just like that. Okay, then another part, prove that this whole part is a cyclic quadrilateral, all right? So using what we proved before and so on and so on. So B1 and this, so all these angles, guys, they are the same. Angle B1 and B2, angle B1 and B2, and the whole angle D. Those are the same from what we just proved, right? Then let us consider part C. All right, this is now C. That AHBE is supposed to be a cyclic quad. Okay, what can we do to prove this? All right, A to H, all right, sorry, from A to H to B to E, this one is a cyclic quad. In order for you to prove a cyclic quad, you must just work with theorems of a cyclic quad, guys. What are the theorems of a cyclic quad? We understand opposite angles. They are supposed to be what? Supplementary. If we are to consider a cyclic quad, opposite angles are supplementary. They add up to 180. The exterior angle of a cyclic quad is equal to opposite interior. Is there anything like that that we can prove? If we can prove that, guys, we are done. All right. What we have here so far, all right, what we can prove so far is that, all right, let's see, guys, what we have. Remember, there's a tangent and a chord. There's a tangent and a chord here. So the whole of this angle A2 and A3 is what is the angle between a tangent and chord AC. So chord AC creates an angle at what? At D. So it follows that the sum of angle A2 and angle A3 must be equal to what? ADC. It is equal to angle ADC from the tangent. The angle between a tangent and a chord is equal to the angle in the opposite segment. So chord, this chord AC, it creates the angle at D. So the whole angle at D, ADC. So we applied the tan chord theorem here. So that is our tan chord theorem. All right. But remember about ADC, guys, what we need here is the exterior angle. If we can use this, guys, we can work with the exterior angle. Since we have A2 and A3, like this interior, it is supposed to be equal to what? This opposite interior must be equal to what? Exterior angle. So let's find the exterior angle. The exterior angle, focusing with angle A, the exterior angle must be what? Must be angle B1. Is there a case that angle B1 is equal to A1 plus A2? Yes, because we proved it before that angle B1 is equal to what? Angle ADC. We proved about this one before. It's already what? Proven. So if angle B1 is equal to angle ADC, therefore, it simply tells us that the whole part here, not B1, actually, the exterior, all right? That's B1, exactly B1. So therefore, it tells us that the sum of these two, they are equal, as they are equal to what? ADC. So therefore, angle A2 plus angle A3 is equal to what? Angle B1. If these two angles, guys, are equal, angle A2 and angle B1, this one, there is nothing. If these two they are equal, guys, we are talking about what? A cyclic quad. The converse part. We are talking about the exterior angle of what? A cyclic quad. The converse now. So this is the converse. So therefore, guys, it's a cyclic quad. AHBE is what? Is a cyclic quad. Is a cyclic what? Is a cyclic quad. So we have got what? The converse of our exterior theorem. The converse, that's the exterior angle is equal to what? Opposite interior angle. So that's the converse of what? Exterior angle of what? A cyclic quad. A cyclic what? Quadrilateral. Just like that. So we have proved that it's a cyclic quad. So to prove for a cyclic quad, you can use what? The converse part. Exterior angle being equal to opposite interior, or you can use what? Opposite angles. If they are supplementary, then it is a cyclic quad. Just like that. Right? Then let us consider 6.2. This diagram below, we have got these points, right? So this is our diagram, and there was a midpoint. What is important is that EOC is the diameter. Then there is a midpoint M. Sorry, OB and AC intersect at M. All right, so they intersect at M, the midpoint of chord AC. So M is the midpoint of chord AC. So it's halfway from A to M and from M to C. All right, so that was it. And we are given these chords intersect at R, and let the angle BEC be X, angle BEC. Let this angle be what? BX, angle BEC. Then 6.2.1, determine with the reasons, all right, the size of the following angles in terms of X. O1. So in terms of what? In terms of X, angle O1 is here. All right, so angle O1, we can simply have this one, guys. We do understand it is the angle that is what? At the center. So from the chord BC or the arc BC, it creates angle O1 and also creates angle E. So angle O1 is the angle at the center. We talked about this before. So that's twice angle E. So it's 2 times X. All right. 2 times angle E. That is angle what? Angle at the center. So this is simply angle at the center is equal to 2 times angle at the circumference, 2 times angle at what? At the circumference. All right, so that was it. Then angle ABO from A to B to O, from A to B to O, which is B1 and what? B1 and B2 combined. That is the one that we are actually focusing on as our angle. All right, so that's the one that we need, ABO. So what can we do to find this angle ABO? So let us see what we have so far. We have got angle O1. We have got angle A1, which is affected here, A to B to O. Yeah, we can use a lot of things. We can actually work out a lot of things. Remember, from the diameter concept, okay, this is 2x. And what we can simply do is that from O to B, all right, we need A, B, O, this other one. All right, so guys, now I was focusing on this one, of which it was still going to help us to find what we want. But anyways, there are angles that we can have or that we can obtain from the chord BC. We can have angle A. Angle A is same as angle E, angles subtended by the same chord or angles in the same segment. So this angle A1 is going to be what? Equal to angle X, which is angle E from our angle E. So that's X. All right. So we're talking about angles in the same segment there. All right. Angles in the what? In the same segment. So from there, ABO can be calculated. Let's say we have got angle at M, which is M3. And we do understand that that angle M3 is what is 90 degrees because of what? This one, the center, from the center O to passing through the chord A to C. From the center, it will be at what? 90 degrees. So M1, M2, M3, those angles are at what? 90 degrees. So that's 90 degrees here. M3 is 90 degrees. From that line, from center to midpoints of a chord, it's going to be at 90 degrees. All right. Since we talked about that, M is what? M is the midpoint. Remember I said M is the midpoint, guys. So that'll be at what? At midpoint. So that'll be at 90 degrees. So here I can say line from center. Line from center to what? To midpoints. To midpoint. To the midpoint of what? Of the chord. So that is the concept that you're simply going to use. Since M is the midpoint, remember those have concept. So we can find AB or the remaining angle AB, or since we have got angles in a triangle, sum of angles in a triangle add up to 180. So since we have got 90 degrees already, the remaining angles, they are supposed to give us what? 90 degrees. So it's simply going to be 90 minus X. All right. That's considering sum of what? Sum of angles. Sum of angles in a what? In a triangle. So that's what you have. So this whole angle at B1 and B2 is 90 degrees minus what? X. Like I said, there are so many ways, guys, so many ways that you can actually use to prove, to state or to find that angle AB O. All right. So that is it. Then here we have got 6.2.2, where we need to prove that AB is a tangent. AB is a tangent to the circle passing through A, E, and R. A, E, and R. All right. From A to E, then to R like this. All right. So they're saying the circle is going to pass through that. All right. So if the circle passes through A, E, and R like this, all right, this is our A, this is our E, and this is our R. Then they are saying we are supposed to prove that AB is a tangent. AB, AB, this is a line AB, this one. From A to B, they are saying it is a tangent, A to B. So to prove that it is a tangent, guys, what can we use? What can we use if it is a tangent? We just have to consider theorems of a tangent, guys. All right. If it is a tangent, we can prove that the angle that is between a tangent and a chord is equal to the angle in the opposite segment. So, can we prove something about angle E, which is angle E1, this one? Can we prove something about angle E1 and BAR? Is that so? Or BAR or BA to C, BA to C. Can we prove that these two are equal? Remember, BAR or BA to M, this one is what is X. So can we prove that angle E1 is also equal to X? If we can prove that these two are equal, therefore we have proved that what we are given there is a tangent, because it follows the concept what the concept of a tangent. We have to work it from what? From that, from the converse theorem, which is from our tan chord theorem, the converse. So that is the converse part that we are simply going to use. So can we prove, or can we work out that angle E1 is equal to X? This one. This is what we need to prove, all right? So let us see what can we do. All right, remember we have got these lines from A to E and from O to B. What we can do from the midpoint concept, because what we see is that A to E to C, this triangle that is formed, it is also having the midpoints of E to O. E to C, O is the midpoint, it's on the center. M is already the midpoint. So the line that joins that from the midpoint concept, if these two lines, if these 2 points are midpoints, then the line that we are going to have, O to M, is going to be parallel with the line from E to A. That is from our midpoint concept. So if these two are parallel, all right, let's talk about them being parallel, that EA is going to be parallel to what? To OB from what? Our midpoint theorem, all right? From our midpoint theorem. So if these two are parallel, I want you to see something. It follows that the angle O1 and the whole angle at E, they are equal, because we're talking about what? F angles, corresponding angles. So corresponding angles are equal. So it follows that the whole angle at E is equal to angle O1. And angle O1, we have it as what? As 2x. So if the whole angle at E here, if the whole angle at E is what? Is 2x. What about E1? All right. So here, the reason why we said angle E is equal to angle O1, we talked about what? Corresponding angles here. The reason being what? Corresponding angles, all right? Corresponding angles, they are what? They are equal. Remember that since these two lines are parallel, since AE is parallel to what? To OB, like I said. So we can find angle E1 because the whole of angle E is 2x. But the first one is x. C E to B is X. So E1 is going to be 2X minus X, which is what? Which is X. So that's our angle. E1 is equal to what? Is equal to X. So if E1 is equal to X here, and we want to prove that is equal to angle A. Guys, this is what we have. So angle A1, remember it is equal to X. Remember we already proved this. And having angle A1 being equal to E1 like this definitely tells us we are dealing with what? With a tangent. So therefore, AB is a what? Is a tangent. Like I said, this is the converse theorem of our tan chord. So it's a tangent to the what? To the circle, which passes through AER like that, all right? To the circle, sorry, tangent to the circle AER, all right? So that's AER like that. So we are simply talking about what? The converse theorem from what? The tan chord, from our tan chord what? Our tan chord theorem. This is how you prove these questions, guys, just like that. Simply, you have to play around the converse part. 6.2.3, prove that this here, okay, is the same, all right? Let us try to figure out what is it that we can actually use. All right. What can we use? We've got these theorems, this and that we have worked with and filled in with that. We need to consider. All right. So that was actually the last part, 6.23. We need to prove that AE squared is equal to 4E O squared plus 4AB squared plus 4ME squared. Is that so? Minus, here there's a minus 4AB squared minus, sorry, 4E squared, then there's a minus here. This is a negative. All right. So let's try to play around what we have. Okay, what is that we can use, guys, here? Do we have any right angled triangle here? Do we have any right angled triangle that we can form? Right angled triangle, remember from the diameter, it creates angle at A, 90 degrees, and also B. So B is at 90 degrees, A is at 90 degrees, but B is limited because we do not have, if we check, there are two right angled triangles, guys, AEC. AEC is right angled since we have the diameter OC, so 90 degrees at what? Sorry, 90 degrees at A2. A2 is what? 90 degrees. And also, B, the whole part here, we can form triangle EBC. But triangle EBC can be limited here because we do not have like B, it's AE, we already have that. AE is there. So we know that. Okay? So we can play around with the first triangle. So in that triangle AEC, it's a right angle triangle. So if it is a right angle triangle, let us apply our Pythagoras theorem from that. It is right angled at what? It is right angled at A. So that's the hypotenuse AC squared is equal to the sum of the square of the shorter sides AE squared plus AC squared. All right. So we have AE. All right. So far I've got AE, but AC we do not have. EC we do not have here. So what can we do now to get rid of that? Can we formulate something equal to those sides that we are dealing with? Anything that is equivalent to these sides AC, because we do not have AC. So can we remove it? The whole of AC is a combination of A to M plus M to C. All right. So meaning to say, it is what? AC is equal to AM plus MC. But remember, from A to C, I mean, from A to M and M to C, they are the same. So we can write it in terms of AM or MC, whatever that you want, because these two, they are the equal. AM is equal to MC. So AC is equal to 2AM or 2MC. This is what? Our AC. Why are we writing or why are we talking about AC? Because we do not have AC, so we must find something equal to that. And what is equal to AC? It is MC. All right? That is what we have from this consideration. Then another part, AM we do not have also on our formula. So we are going to make adjustments for that AM. But let's get rid of that. So AC, we no longer have this. We have A to E here on our formula. So let's keep this one. EC, we do not have EC here. Let's find something equivalent to that EC. From E to C, it's a combination of what? These two. From E to O and from O to C. But remember, from E to O, it is the same as what? It is the same as from O to C. These two, they are the same. So EC, you can write in terms of EO as what? 2 times. So it's 2 times what? EO. So we have replaced this. Let's rewrite in terms of our replacement and see if we are going to win, because we do not need these ones. EC, we do not need this. So EC can be replaced with 2EO, then we square it. Okay, AE, we're just going to remain with it. From A to C, remember it's what? 2AM. So that's 2AM, we square it, which was going to give us 4EO squared. All right, which is equal to AE squared plus 4AM squared. We can see that's those 4, we have them, 4, this 4, that we have them. But we are limited in this right-angled triangle, we are limited. So do we have any other right-angled triangle that we can use? Any other right-angled triangle that we can use besides this EB what? EBC. We cannot work with that EBC. All right. Another right-angled triangle that I can figure out is this one that has got these letters, because I need BM and I need, all right. This EO is part of my answer already here. I have it. A to E, I have it. But AM, so I have to get rid of AM from A to M, this one, using what? AB and MB. So I'm going to use this right angle triangle AMB, this one. So from right angle triangle AMB, we can replace AM because of that. All right, from our Pythagoras theorem, AB squared, our hypotenuse, is equal to MB squared plus what? MA squared or AM squared. So you can see that AM, we can get rid of that AM squared. Let's make it the subject. So it's going to be AB squared minus MB what squared. That's equal to AM squared. So that is it. So using this AM squared, we can play around from our Pythagoras. This is where we are, so we can substitute this. Want to get rid of this. The one that we do not have on our formula here. So it's going to be 4EO squared is equal to AE squared. We have it plus 4 into what? AM squared. AM squared is written in terms of what? AB and what? MB squared. So do we have AB? All right. AB is part of our formula. And also MB is part of our formula. So this, we can simplify it and write it in terms of the answer that we have in there. So we simply have to make what? AE squared the subject. So let's make AE squared the subject. So I'm simply going to take this bracket to the other side. So it's 4e all squared minus 4 into this bracket of what? AB squared minus MB squared, which is equal to what? AE squared. All right. Yeah, there they played around with you guys on this one. All right. Anyways, let us simplify the left-hand side. 4e all squared expanded by the bracket negative times positive, that's a negative 4ab squared, negative times negative, that's a positive 4mb squared. Yes, yeah, they tried by all means to play around with you. But anyways, that is how you could have figured out working with the two triangles that contain the same letters as what you are to prove. You're focused on these letters. What you do not have, get rid of it. What you do not have, get rid of it. What you do not have, get rid like that until you remain with the letters that are on your question, the one that you're being asked to prove. Then from there you can prove, guys. So that was it for 100 marks. That is it, guys, for these 100 marks. So let us do revise in as much as we can. Prepare yourselves for the examinations that are ahead of time. But for now, that is it till we meet again.